In this video, I'll be talking about limiting reactant. So a limiting reactant, as we'll see on our definitions here, is going to be the reactant responsible for the chemical reaction reaching completion. So in a chemical reaction, we usually have a reactants side and a product side. When we're comparing a limiting reactant to an excess reactant, whichever one runs out first, meaning there is going to be none left over, we call it the limiting because it limits how much of our products we can make. Usually another one of the reactants is an excess, and that one is going to have more that could still react, but since there's nothing left to react with, no more products can be produced. So whenever we're talking about limiting an excess reactants, we're always talking about it in relationship to a reaction. And one of the most important things we need in order to kind of figure out information is a balanced reaction. So we would need to balance this reaction first. And thinking about what kind of this balancing means, the one here means that I have one molecule of N2, that I have 3 molecules of hydrogen, and that I have 2 molecules of NH3. Now we can think of it as individual counts, but realistically, when we are talking about reactions, we're talking about them on a very large scale. So we have these numbers, instead of representing 1, 3, and 2 individual molecules, represent 1, 3, and 2 moles of the molecule. So really, we kind of assume that this means 6.02 times 10 to the 23rd. That we mean that we have 3 times 6.02 times 10 to the 23rd here, and then we mean we have 2 times 6.02 times 10 to the 23rd molecules of each of these. It's still counting, but it's just counting on a number that is going to be more accurate for what is happening, but still easy enough for us to understand. So looking at this reaction, this would be a perfect ratio. We would have none left over. Neither of these would be in excess or limiting. They would be perfectly set up to completely produce what we need to produce and not have any excess. However, that is not always the case. Sometimes we have not a perfect amount. And so we would want to figure out then, what is my limiting? So here is a pictorial description of kind of limiting and excess. So looking at this, it may not be as obvious to see which one is going to be my limiting, which one's going to be an excess. So I know the ratio is, I can have 1 nitrogen and 3 hydrogens to make one of my products. So we can kind of look and see if I have 1 of that and 3 of that. I still have more I can produce, so I'll do another one. Still have more I can produce. Even still more. Okay, so I've used up 4 red ones, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can cross the rest of these off. So that means I can't make any more products. Because I've used up all of my hydrogen, I am not able to produce any more products, even though I have more nitrogen that can be used. No more product can be made because there's nothing left to react with. So I would say that this is my limiting reactant and this is my excess reactant. So that same concept will apply to our math. As always, we need to start with a balanced equation. Now this one's going to be a little easier to balance because everything will be a 1. We're starting here with numbers in grams. So before we can kind of compare how things are going mole-wise, we need to compare starting with grams and doing some stoichiometry. The best way to do this is to reach the answer for how many, because it's asking us of mass of FES formed. We want to calculate how many grams of FES we can form from each of these starting materials, and then kind of see whichever one's less, because whichever one is less is going to be the one that has limited us to make that less amount. So we'll start with our setups. Okay, I've kind of set up what I know is going to be a 3-step conversion and put the molar masses above each of the compounds in the reaction. So we'll start by converting from grams of iron with a molar mass of 55.85 to moles of iron. And because we're trying to figure out how many grams of FES we're forming, we're going to go from moles of iron to moles of iron to sulfide. These are a 1-to-1 ratio, so realistically we won't need to change much, but we always need to make sure that we are setting up that ratio because it won't always be the same number. Then we can cancel out mole of FES and go to grams of FES, which is 87.92, which will give us a total mass, if we do to sig figs, of 12.0 grams. So that tells us, based on starting with 7.62 grams, we could theoretically make 12 grams if we had enough sulfur, but we don't know which one we have more of. So that's why we're going to do a second equation with our sulfur to see how much iron to sulfide we can make. So similarly, we'll convert with our molar mass, but this time the molar mass will be of sulfur. And then we'll go mole to mole again. Still going to be 1-to-1 based on this reaction. And we'll notice that the last few steps are the same since we're going to the same product. So our final number at the top here is identical. The beginning part is what is changing, right? The fact that we're having the 8.67 divided by 32 instead of 7.62 divided by 55. But here we're going to find that based on that amount of sulfur, we would be able to make 23.8 grams. So theoretically, if we had enough iron, we could make 23.8 grams with the sulfur we have. But as we can see, our iron says we can only make 12 grams. And so based on that, we're being limited by the amount of iron we're told we can make. That means, to answer the question below, the limiting reactant or reagent is going to be our iron. While the sulfur is going to be excess. If we could find more iron, there would be sulfur left to react with it. But based on our definition of limiting, the iron will completely run out. So we'll do one more example. You can see this one has a little bit more going on in terms of coefficients. So this one is asking us what mass of our product here can be made if we have this amount of our reactant reacting with this amount of our other reactant. So again, I'm going to set up the two conversions. So in this case, we have the same amount of reactants in terms of grams, but this is evidence of why grams is not sufficient enough to determine the limiting reactant, because as we're going to see, the same starting amount of grams of each of our reactants does not yield the same predicted amount of grams for the product. So we'll start with our top conversion. If we find our molar mass of this, we're going to take 3 hydrogens plus 3 carbons plus 6 hydrogens, which will give us 42.09. So we want to convert using that number into moles. And because we are converting from moles of C3H6 to moles of C3H3N, we are going to use our mole-to-mole ratio. Unlike our last problem, we have coefficients here. So for every, based on the equation, for every 4 moles of C3H6, we will produce 4 moles of C3H3N. Then we want to convert from mole to gram. Now remember, the only time we're not having 1 with mole is in that mole on top of mole step that we just did. When we're doing our other conversions, we're always thinking of those conversions in terms of 1 mole equals either the molar mass, the volume at STP, or the amount. We again would need to find our molar mass. Our molar mass of this, when we add the 3 hydrogens, 3 carbons, and 1 nitrogen together, is 53.07. And if we multiply, we're going to find that according to this, we would be able to make 27.2 grams of our product. We need to do our other reaction to see if that is in fact how much we make, or if this reactant will limit us to make less. So again, we need our molar mass. 1 oxygen plus 1 nitrogen is going to be 30.01. We need to get to moles, so that way we can use our mole-to-mole ratio. In this case, it's for every 6 mole of NO, we have 4 mole still of our product. And then because we're solving for the same thing, our last steps will look the same. As I said, we're going to find that the amount we produce is not identical despite starting with the exact same amount. So here we're going to find we can make 25.5 grams, which is more than, or sorry, is less than the other one, meaning that the true amount we will make is that 25.5. And that C3H6 is excess, and our limiting reactant would be NO. once you know the limiting reactant, so once I know that um, nitric oxide is my limiting, then I don't really want to be using the C3H6, the propylene, to solve anything. If I asked other questions about how much water is produced or how much nitrogen gas is produced, only the nitric oxide would be giving me the correct value for my theoretical yields. If I tried to use the propylene to solve for those, I would be getting inaccurate predictions. So once you determine your limiting reactant, you don't really want to be using your excess reactant to calculate unless it's specifically asking you about something in relation to the excess.